Okay, so now we're going to be doing a warm-up about the chain rule differentiation or the chain rule special math kung fu technique. And you have problem K and problem L from number 16 at page 127 of your note book. Those are the last of number 16, so those are supposed to be the hardest one. So as usual, you should pause the video, try those by yourself, and then come back for the solution. So I hope it went well. Let's do it now. So I rewrote the first one, so number 16. I rewrote this one right here, number 16k. So y is equal to 2x squared plus 2x to the power of 5 multiplied by 2x cubed minus 1 to the power of 4. Of course, it's a multiplication, so you should prime, not prime, plus not prime prime. That's what I wrote right here. Which one is going to be your first prime? Well, it's going to be 2x squared plus 2x to the power of 5 prime multiplied by 2x cubed minus 1 to the power of 4 multiplied by 2x squared plus 2x to the power of 5 multiplied by 2x cubed minus 1 to the power of 4 prime. To prime those, you'll have to use your special rule, your u to the power of n prime rule. It's equal to n multiplied by u to the n minus 1 multiplied by u prime. So you have to use your u to the power of n prime because remember that u is a function. So you have to use this rule right here to prime this one and this one. So y prime is going to be equal to, it's going to be equal to 5. So you bring down the exponent. It's going to be 2x squared plus 2x, all of that to the power of 4, multiplied by the inside prime, so the u prime right here. So it's going to be 2x squared plus 2x, all of that prime. So this is only, this part right here is this part right here. I still have to multiply by 2x cubed minus 1 to the power of 4 plus 2x squared plus 2x to the power of 5. Then I bring down the exponent, multiply by 4, 2x cubed minus 1 to the power of 3. Multiply that by the inside prime, so 2x cubed minus 1. So all I have to do now, well, this part is this part right here, just to show you where it comes from. Now all I have to do is prime this u, the u prime, prime this u. There's actually two u's. There's a u1 and a u2. And after this step, I'm going to put my equal symbol. The derivative is done after this step. So the derivative is going to be done after this step. But afterwards, we'll have to simplify. So afterwards, it's going to be simplifications. So it's going to be 5 multiplied by 2x squared plus 2x. All of that to the power of 4. And I will multiply by the derivative right here. Bring down the 2. It's going to be 4x plus 2 because derivative of x is just 1. Multiplied by 2x cubed minus 1 to the power of 4 plus 2x squared plus 2x to the power of 5 multiplied by 4, 2x cubed minus 1 to the power of 3 multiplied by derivative of this one right here. It's going to be 6x squared because derivative of 1 is 0. So the derivative is done right now. All I have to do now is factor out the common factor. So I can see that this bracket right here is exactly the same as this one, only the exponents changes. Same thing for that one with that one. So now I have to factor out the same expressions. So I have to factor out first my 2x squared plus 2x bracket. But this bracket is going to be to the power of 4 or 5. Well, I have to factor out the one that is the smallest. So I can only factor out 4. Same thing for this one and this one. I will have to factor out 2x cubed minus 1 to the power of 3. And then I'm going to be asking myself what's left inside the last parentheses. Well, 5 is going to be there still because I did not factor out 5. This one, well, it's gone because it's been factored out. This one is right here, 4x plus 2. This one is to the power of 4, but I removed 3, so there's still one left. It's going to be 2x cubed minus 1. So this one is still there. Plus this one, I got 5. 4 were removed, so I still have 1, 2x squared plus 2x. All of that multiplied by 4. Then I factored out 3, so this one is gone. And I still have 6x squared. So that's what's going on right now. And I can just multiply those two together. Sorry. Multiply those two together to get 24x squared. Just did that right there, just to have a bit more space. And now I have to expand this bracket right here. So I will have to expand, 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 expand. So I'm going to continue here. It's going to be 2x squared plus 2x to the power of 4 multiplied by 2x cubed minus 1 to the power of 3, big bracket. 5 multiplied by, well, it's going to be 8x to the power of 4, this one with this one, minus 4x plus 4x cubed, this one multiplied by this one, minus 2. All of that between brackets because afterwards I will have to expand my 5. Plus here I expanded, I multiplied 24 by 2. It's going to be 48x to the power of 4 plus 48x to the power of 3. Then I'm going to have this. It's going to be equal to 2x squared plus 2x. All of that to the power of 4, 2x cubed minus 1 to the power of 4. Then I expand my 5, so it's going to be 40x to the power of 4 minus 20x plus 20x cubed minus 10 plus 48x to the power of 4 plus 48x to the power of 3. And then you have to combine the terms that are with the same power of x. So this one with this one, there's going to be also this one with this one. So you have to combine those. So it's going to be 2x squared plus 2x, all of that to the power of 4, 2x cubed minus 1, all that to the power of 3, and then it's going to be 88x to the power of 4 plus 68x to the power of 3 minus 20x minus 10. You stop here. Stop here for the exam. I will not ask you to simplify more, but if you check the answer in your notebook, it's not going to be this version. The version that you will have is going to be slightly different. They just factored out the 2 right here from those two 2's. So you can factor out a 2. It's going to be 2 to the power of 4 because all of that bracket is to the power of 4. So if you factor out 2, it's going to be to the power of 4. There's going to be left x squared plus x to the power of 4 multiplied by 2x cubed minus 1 to the power of 3. And then you can also factor out 2 from that bracket. So I factor out 2. It's going to be 44x to the power of 4 plus 34x to the power of 3 minus 10x minus 5. And then they multiply 2 to the power of 4 with 2, so it's going to be 32 multiplied by x squared plus x to the power of 4 multiplied by 2x cubed minus 1 to the power of 3 multiplied by 44x to the power of 4 plus 34x cubed minus 10x minus 5. So this is the most simplified version, but as I told you, you can stop here if you'd like. It's not required to continue. For me, you can just stop with this answer right here. But if you prefer to continue, you can also continue. There's no problem with that. So you can take a picture. And once it's done, I'm going to take the L problem. So I hope you're ready. It's right here. So now the L problem is right here. So I just rewrote my function as this. I rewrote as a parentheses to the power of 2 over 7 because this parentheses is to the power of 2 and a root is a fractional power. So you can bring that down as the denominator of the power. And then I just have to notice that this is just u to the power of 2 over 7. So I can use the same rule I just did. So for f prime, I'm just going to bring down the 2 over 7 in front. It's going to be multiplied by, same bracket, x plus 3 over x squared minus 4, all of that to the power of 2 over 7 minus 1. All of that multiplied by the u prime. So it's going to be multiplied by x plus 3 over x squared minus 4, all of that prime. So you got to be careful to multiply by the u prime situation. So that is a 2 over 7 right here. So you got to be careful with that one. So f prime is going to be equal to 2 over 7 multiplied by x plus 3 over x squared minus 4, all of that to the power of negative 5 over 7. When you minus 2 over 7 minus 1, it's going to be negative 5 over 7, multiplied by, this situation is a u over v situation. It's a quotient situation. So it's going to be a prime multiplied by not prime minus not prime multiplied by a prime, all of that over denominator squared. Now you can put the first one, x plus 3 prime, x squared minus 4 not prime, x plus 3 not prime, x squared minus 4 prime. So it's a prime not prime minus not prime prime over v squared, the situation. So now I see that I have a negative exponent right here. I can just switch numerator and denominator just to simplify that a little bit. So it's going to be x squared minus 4 over x plus 3, all of that to the power of 5 over 7, multiplied by the prime of this one. Well, prime of x is 1, prime of 3 is 0, so it's just going to be 1 multiplied by x squared minus 4 minus x plus 3 multiplied by prime of that one is going to be 2x multiplied by 2x, and prime of negative 4 is going to be 0, so it just disappears. All of that over x squared minus 4 squared. Now I will have to expand the top to simplify because right now derivative done. Derivative done. So all the points for doing the derivative, you got 100% for doing the derivative because there's no more primes anywhere. So your derivative is done. Now you only have to simplify. So what I'm going to do, I'm going to expand, distribute, and I will also distribute the exponent on top, exponent at the bottom. So it's going to be very nice. It's going to look like this, 2 over 7 multiplied by x squared minus 4 to the power of 5 over 7. Why am I doing that? You will see it very soon. It's because you have also an x squared minus 4. X squared minus 4, x squared minus 4. You need to simplify those. Multiplied by x squared minus 4, x squared minus 4, minus 2x squared minus 6x. All of that over x squared minus 4, all of that squared. Now you can see that this one and this one are the same factor, but this one is on top, this one is at the bottom. But since this one is smaller than 2, I'm just going to be canceling that one right here and minus 5 over 7 right here. Just have to minus the exponent of the one that is the smallest. So this one will disappear, and this one I will minus it 5 over 7. So it's just going to be equal to 2 over 7 multiplied by 1 over x plus 3 to the power of 5 over 7 multiplied by this one is going to be negative x squared minus 6x minus 4, all of that over that bracket, x squared minus 4. Now it's going to be 2 minus 5 over 7, so it's going to be 9 over 7, because 2 is 14 minus 5, it's going to be 9 over, that is a 9 right here, 9 over 7. The power of 9 over 7, and so you can just bring all of that to the same fraction, so it's going to be 2 multiplied by negative x squared minus 6x minus 4, all of that over x plus 3 to the power of 5 over 7 multiplied by x squared minus 4 to the power of 9 over 7. You are allowed to stop here. You can stop here if you'd like. If you want to have a more simplified version, you can bring out the negative exponent, the negative symbol right here, negative 2. It's going to be x squared minus 6x plus 6x plus 4. All of that over, well, these have all the same fractional exponents, so it's going to be a root, 7 root of x plus 3 multiplied by x squared minus 4. This one is going to be to the power of 5, and this one is going to be to the power of 9. So this is the more simplified version, but you are allowed to stop here with this one right here. So you can take a picture of that, and I hope it went well. Remember that these are the hardest ones, so you are supposed to struggle doing this. So it's meant to struggle. So this is really good practice though for your exam. So I hope you enjoyed it, and do not hesitate to write to me if you have any questions. Have a nice one, and see you next time. Bye.